So hello everyone, welcome to this video, and so in this video I'm going to show you my memory creation tool. So it creates memory for you, XOR memory of course. So let me show you. So here I have the actual script. It's Python script because I love Python and it's quite easy to code on. So let's create a standard 8 by so bit width, address bit width. Let's create like 6. It's a pretty good number. And amount of inputs, outputs, for now just one. I'll show you in a minute as that, like 2 inputs or 2 outputs mean. So let's search for unnamed, because that's how it's then named. And here we go, here's our memory. So, as you can see, it's pretty simple memory. It's a self-aware XOR memory. So we have 3 bits, 3 blocks per bit, which is pretty efficient. I have 6-bit address, 8-bit input and output, and 1 input to set the stuff. So let's just I guess actually let's make just a connect a counter, and let's just input a count because I'm too lazy, and wire it right here. The right bit is the least significant one, as always. It's same in decimal, same in every other counting system. Now let's connect the button, connect it to here, and let's just click 64 times, which is pretty simple. So let's just count 1, 2, and yeah, as you can see there is 2 bits activated, but that happened because of how I stored the memory. I mean, when we set something, if those gates are loose, so they're like we don't have anything connected to them, then they'll just output 1 constantly. So right now they're constantly outputting 1, but if we'll do that, as you can see, I didn't connect anything to these gates now because I disconnected this, but as you can see, the gates that we connected to now output 0. So yeah, that's just a note when you'll use that tool, if you will use that tool. I'll give a link to a GitHub page in the description. So as you can see, it's a counter, nothing really amazing here. It's memory. So that's pretty neat, and other memory will have still 8 bits. Now let's go with just 3-bit address. I don't think we need more. And let's have 2 input and output. So we have 2 inputs and 2 outputs. And so let's go to unnamed again. Here we go. Here's unnamed. Pretty chunky memory right now. And so as you can see, here's 2 inputs and 2 outputs. And you can ask, okay, what the hell is this? Why is that a thing? Well, it's required for you to be able to actually set read and write at the same time. So you can write something to this memory and read from this memory from 2 different addresses. So let's write something here. Let's write just a checkered pattern, why not? So we'll use the loose gate thing to our advantage, like that, and enable this and set. And as you can see, here's our checker pattern, pattern. And now, so here's at cell 000, we're looking at this part. So let me just do that. So at address 1, we have this pattern, part of the pattern, and this address we have this part of the pattern. So as you can see, we just wrote something to this memory 2 times at the same time. So we wrote something in parallel, and we obviously, as you already saw, we can read at 2 addresses at the same time. So for example, we'll have, I don't know, some kind of weird abomination thing like that. So we can create this kind of memory. That's not what I wanted to do. Replace this file, please. So let's check this beautiful memory, and as you can see, now we can write 8 different numbers at the same time. We could pretty much create 8 by 8 by 8 memory, so we could have 8 inputs, 8 outputs, 8 different so we could write pretty much we could write the entire memory and output the entire memory. So it's pretty neat. I'm not quite sure where can you use this kind of memory. It's not very usable, but I mean, maybe you'll find some use to it. But yeah, for now, thanks for watching. Again, the link to first my Discord server will be in the description, and my GitHub thing too. There's just one file. I'm not sure why I'm using GitHub, but you can fork it, I guess, and you could make something else. But yeah, for now, thanks for watching. I wish you a good day. Bye.